Hi, welcome back. Today we're doing some extra practice with graphing parabolas. First, we're going to do tables, and then we're going to graph without tables. Okay, first problem. F of x equals negative x squared plus 4x minus 3. All right, so to do this, I'm going to choose some x values and see how that goes for me. So I'll start with 0. All right, if I plug 0 in for x, I have negative 0 squared plus 4 times 0 minus 3, which equals negative 3. So when x is 0, y is negative 3. And that's this point right here. 0, negative 3. That's my y-intercept. Okay. Now I'm going to do x equals 1. So I plug that in. Negative 1 squared plus 4 times 1 minus 3 equals. I throw that in my calculator and I get 0. So the point 1, 0 should be on my graph. And that's one of my x-intercepts, so I'm going to label it. Next, 2. I plug 2 in. I throw that in my calculator and I get back 1. So the point 2, 1 is on my graph. So far, I'm not sure if this is a special point or not, so I'm not labeling it yet. Next, 3. I plug 3 in. Plus 4 times 3 minus 3. I throw that in my calculator and I get 0. That's an x-intercept, so I label it 3, 0. Oh, it looks like I actually have all of my important points because this is where I change direction, if you can see, based on symmetry. This is between those 2 points. All right, I don't have to do any more except connect with a smooth curve and make sure I extend beyond any intercepts. So sometimes students will stop right here. You don't want to stop here. The arms of the parabola go on forever. And since this turns out to be an important point, I'll label it. It's my vertex, and the vertex is at 2, 1. The last thing I need to label is my line of symmetry. And that's at x equals 2, because that's the line that cuts my parabola in half. And this parabola opens down. Its vertex is 2, 1. Its x-intercepts are 1, 0, and 3, 0. And the line of symmetry is x equals 2. Notice I have my classic shape. I have a U shape. It's symmetric across the line of symmetry, and it's opening down. It doesn't always have to open down. Okay, next. F of x is negative 2x squared plus 4x. I'll start my table of values at negative 1. Okay, so that's negative 1 times, negative 2 times negative 1 squared plus 4 times negative 1. And if I enter exactly this, be careful with your negatives, into my calculator, I get back negative 6. So the point negative 1, negative 6 is on my graph. Now, I don't want to label it because I don't know if this is a special point yet. The only points I label are my vertices and intercepts. I don't know if this is a vertex. Okay, next point, I'll do 0. Well, if I plug 0 in, I get 0. So 0, 0 is on my graph, and this is definitely an intercept. See how it's on one of my axes? It's actually on both. 0, 0. Next, I'll do 1. I plug that in. In my calculator, I get back 2 over 1 up 2. Don't know if that's special yet, so I'm not labeling it. Next, I'll do 2. Negative 2 times 2 squared plus 4 times 2 equals. I throw that in my calculator, I get back 0. So over 2 up 0 is on my graph. And since this point is exactly between these two, I know that the middle is where my line of symmetry is, and it's also where my vertex is. So it looks like I can claim this to be my vertex. And this was the point over 1 up 2. Okay, and I have all of my intercepts because this is a y-intercept and an x-intercept. And this is an x-intercept. So I'm going to connect with a smooth curve, making sure not to stop at any intercepts and to go straight through them. Okay, so I didn't do a very good job on this one, everybody. Notice this looks a little bit pointy. You never want a pointy parabola. Should be curved. I hope that looks a little bit more curved. Okay, the parabola opens down. The vertex is at 1, 2. The x-intercepts are 0, 0, and 2, 0. My y-intercept is 0, 0. My line of symmetry, oops, I forgot to label it, is x equals 1. Next. Okay, here I have f of x is 2x squared plus 4x plus 1. I'll start this table of values with -3. Okay, for y, I have 2 times -3 squared plus 4 times -3 plus 1, which equals, I throw that in my calculator and I get back 7. So -3, 7 is on my graph. Here it is. I don't know if that's going to be a special point, so I cannot label it yet. Next, -2. 2 times -2 squared plus 4 times -2 plus 1 equals, I throw that in, I get 1. -2, 1. There's that. -1, I throw that in, -1 squared plus 4 times -1 plus 1. I get back -1 right here. Oh, look, it looks like I'm going to have x-intercepts that are not whole numbers. I'll need to do some estimating this time. 0, I throw that in. 2 times 0 squared plus 4 times 0 plus 1 equals 1. I don't even need a calculator for that. Look, anything times 0 is 0. These terms mean nothing now. Anyway, 0, 1 over 0 up 1. It's on my graph. Let's do 1. I don't think I need any more because I have symmetry and I've already changed directions. Okay, the middle of my parabola is x equals -1. That's my line of symmetry. I can write down my vertex. It's -1, -1. My y-intercept is right here. I should label it. It's at 0, 1. My x-intercepts, I'm going to have to estimate. That's because they're not at whole numbers. And my parabola opens. Well, let's connect this to make it really obvious that it opens up. All right, let's look at these. I think this looks like about -1.8. So I'll say x is -1.8, 0, and I'll think this looks like about 0.2 and -0.2, 0. And I'll label them -1.80. This is an estimate, and -0.2, 0. All right, that's this page. Let's do the next one. Okay, now we're going to sketch parabolas without a table of values, and this is very important. So let's see. First one, I have y equals x squared plus 2x minus 3. In order to find the x-intercepts, I need to factor and apply the zero product property. Some of you know how to use the quadratic formula. It's not the better choice, even if everybody knew how to use the quadratic formula. The best choice here is factoring because these are easy to factor. Okay, so I do my little x box. Notice that the coefficient of x squared is 1, so all I really need is the x. I don't really need the box. Okay, I need something that multiplies to -3x squared and adds to 2x. factors of -3. That's going to be 3 times -1 adds to 2x. So 3x and 1x gets me that y is equal to x plus 3 times x minus 1. There, and from here I can find my x-intercepts by setting this equation equal to 0, because when y is 0, I'm on the x-axis. So x plus 3 equals 0, x equals -3, x minus 1 equals 0, x equals +1. My x-intercepts, oh, focus, are -3, 0, and 1, 0. I'm just going to look out the window to see if be done in just a moment. Sorry about that sound in the background. Okay. Now we find the y-intercept. The y-intercept is very straightforward. I plug 0 in for x. Y is going to equal 0 squared plus 2 times 0 minus 3, which is just -3. So my y-intercept is 0, -3. Now for the vertex. There are 2 methods for the vertex, but I like the one where we go between the x-intercepts, especially when the x-intercepts are whole numbers. -3, -2, -1, 0, 1. If I go to the middle, the x part of my vertex is -1. So the y part, if I plug in -1, I get -1 squared plus 2 times -1 minus 3, which equals 1 minus 2 minus 3, which equals -4. So my vertex is at -1, -4. Now I can sketch my graph. Okay. I only have to label my important points. Here's one of them. -3, 0, that's one of my x-intercepts. 1, 0, that's another one of my x-intercepts. 0, -3. That's my y-intercept. -1, -4 is my vertex. Okay, smooth curve. And don't forget to label your line of symmetry. It goes right through the vertex. X is -1 for all points on this line. Okay, next. We have y equals -2x squared plus x plus 1. First, I'll find my x-intercepts. I don't like this negative in front, so I'm going to factor it out. This becomes -2x squared plus x plus 1, and I'll factor this. Because the coefficient of x squared is a number other than 1, I'm going to use both the x and the box. Okay, so I place 2x squared in the upper left of my box. I place 1 in the bottom. I need to multiply to 2x squared because 2x squared times 1 is 2x squared. On the bottom, I know I need to add to x. So what multiplies to 2 and adds to x? Oh, pardon me, this should be minus. And this should be minus because I factored out a -1. And now I'm multiplying to -2x squared. Okay, that's going to be -2x times 1. If I put them in, -2x, 1. I have 2x here, x here, -1 here, and +1 here. And I get that y is equal to -2x plus 1 times x minus 1. I set that equal to 0 because I'm trying to find what x is when y is 0 since I'm on my x-axis. 2x plus 1 equals 0. Subtract 1 from both sides. I get 2x equals -1. So x is -1/2. And from this one, I have x minus 1 equals 0. So x is +1. And my x-intercepts are at -1/2, 0, and 1, 0. Okay, now I need my y-intercept. I have y equals -2 times 0 squared plus 0 plus 1. Both of these terms go to 0, and my y-intercept is at 0, because that's what x was, 1, because that's what y is. Now we find the vertex. Okay, I need to go between -1/2 and 1. Well, it won't be as easy as the previous problem because I don't have all whole numbers, but I'll find the average of these two values by doing -1/2 plus 1 and dividing by 2, which equals 1/2 divided by 2, which is 1/4, or 0.25. Then I throw that into my equation and I solve for y. Y equals y equals -2 times 0.25 squared plus x plus 0.25 plus 1. I throw that in my calculator and I get 1.125. So my vertex is at 0.25, 1.125. Okay, now I can sketch. I have my x-intercepts at -1/2, 0. And 1, 0. I have my y-intercept at 0, 1. I have my vertex at 1/4, which is about here. 1.125, which is about here. And now I can sketch. Don't forget your line of symmetry. X equals 0.25. And that's the whole graph. Okay. The last one says y equals 3x squared plus 5x plus 2. But that is a typo. It should be y equals 2x squared plus 4x minus 6. We don't have time to do it. So we're not gonna. Have a great day.